In this video, I'm going to show you how to solve logarithmic equations with the laws of logarithms. So first of all, let's take a look at this equation on the left-hand side. We want to solve log base 5 of x plus log base 5 of 3 equals 2. Now, the way to solve this kind of equation is to try to combine all of the logs into a single log. Remember that addition between logarithms of the same base can be turned into multiplication of both of these expressions within a single logarithm. So we can turn this log base 5 of x plus log base 5 of 3 into log base 5 of x times 3, or just 3x. So log base 5 of 3x is equal to 2. Now we can exponentiate both sides to get rid of the logarithm. We can take 5 to the exponent of the left-hand side, so 5 to the exponent of log base 5 of 3x is equal to 5 to the power of 2. And because our base here is exponentiated to a log of the same base, this 5 and the log base 5 cancel out, and we've just got this 3x on the left-hand side. So 3x equals 5 squared. 5 squared is 25. And we can just divide by 3 to get x equals 25 over 3. And there we go. There's our solution. Now let's go ahead and solve the equation on the right-hand side. Natural log of a cubed plus 4 is equal to 2 times natural log of a. Again, our strategy is the same. Just combine the logarithms. So first of all, let's get the logarithms on the same side. Let's just subtract off this natural log of a cubed and get that on the right-hand side. So we'll get 4 is equal to 2 natural log of a, and then minus natural log of a cubed. Now we want to go ahead and combine these logarithms on the right-hand side. Now first what we need to do is we need to get rid of the coefficients in front of the logarithms. This logarithm has a coefficient of 2, so we can move that inside the logarithm as an exponent. So we'll have 4 equals natural log of a to the power of 2, a squared, minus natural log of a cubed. Now we can go ahead and combine these logarithms, remembering that subtraction outside of logarithms turns into division inside of a logarithm. So 4 is equal to natural log of a squared divided by a cubed. And that can be simplified a bit. So 4 equals natural log of reduce top and bottom by a squared, so just 1 on top, and a on bottom. Now natural log, remember, that's log base e. So we can cancel this out, this natural log, if we raise e to the power of each side. So e to the 4th is equal to e to the natural log of 1 over a. Then e will cancel with that natural log, because the base here is the same as the base of the logarithm, because the base here is being raised to a logarithm of the same base, and we just have e to the 4 equals 1 over a. Now we can just go ahead and flip both of these fractions and get a is equal to 1 over e to the 4. And there we go. There is our solution. Here are some more problems. Let's start with the one on the left. Solve a half log base y of 9 plus log base y of 5 equals 2. Again, our strategy is to just go ahead and combine the logarithms to start with. So we need to get rid of this coefficient a half in front of this logarithm here. So we'll go ahead and use that logarithm rule that we can move this a half into the expression here, into the 9, as an exponent. So this will become log base y of 9 to the half power, and then plus our log base y of 5 is equal to 2. Now 9 to the half power, that's just the square root of 9, which is 3. So we really have log base y of 3 plus log base y of 5 equals 2. And addition outside of logarithms turns into multiplication inside of a logarithm. So we can combine this log base y of 3 plus log base y of 5 into log base y of 3 times 5, which is 15. And then the right-hand side stays the same, that's just 2. And now we want to get rid of that logarithm. The way we've been doing this is by raising the base of the logarithm to the power of both sides of the equation. So take that base of y, raise it to the log base y of 15, which is the left-hand side, and also raise it to the right hand side. So that's equal to y squared. Now because this base y matches the base of the logarithm in the exponent, they cancel out and we just have 15 on this left hand side. So 15 equals y squared. So that means we can find y by taking the positive or negative square root, and we get y equals root 15, or y equals negative root 15. But be careful here. Remember that the base of a logarithm can't be negative. And y here is the base of a logarithm in the initial equation. So we can't have y be negative. We cannot have y be negative root 15. Only y equals positive root 15 is a valid solution. Alright, now let's tackle the problem on the right hand side. Solve 3 log base 2 of x equals log base 2 of x minus 4. Our strategy is the same. Let's move the logs to the same side so that we can combine them. So let's go ahead and subtract off this log base 2 of x from the right hand side, move it to the left hand side, and get 3 log base 2 of x minus log base 2 of x is equal to negative 4. Now let's get that coefficient 3 off of the logarithm, just move it inside of the logarithm as an exponent. So log base 2 of x to the third minus log base 2 of x equals negative 4, and then subtraction outside of logarithms turns into division inside of logarithms. So we just have log base 2 of x cubed divided by x is equal to negative 4. We can simplify that division and get log base 2 of just x squared is equal to negative 4. Now we'll go ahead and use both of these sides as exponents, where the base is the same as the base of the logarithm. Base is 2. So 2 to the log 2 of x squared is equal to 2 to the negative 4. And because this base here matches the base of the logarithm in the exponent, we can cancel that out, and we just have x squared. So x squared is equal to 2 to the negative 4, which is just 1 over 2 to the fourth, and 2 to the fourth is 16, so 1 over 16. So we can take positive or negative square root here, so x equals positive square root of 1 over 16th, which is just 1/4, or x equals negative square root of 1 over 16, which is negative 1/4. But again, be very careful here. Remember that x is an argument to a logarithm, and you can't take a logarithm of a negative number. So x cannot be negative. So that means this solution, x equals negative 1/4, is no good. So we only want to take the positive solution for x equals 1/4. Now we know how to solve logarithmic equations using the laws of logarithms. And in the future, we'll continue to learn more about logarithmic functions.